Okay? Well, it just so happens that's the same thing in this one, isn't it? So if we look at the member, and normally this is what I always just kind of label it, member, and that member is probably CF or CDF, might be more appropriate. And we'll draw a free body diagram of that. Easy enough, right? That's just a beam. And we've got something going on here at C. We've got something going on here at D. And then at F, we've got this force right here, excuse me, which we know to be 10,000 pounds, right? Well, what's happening, excuse me, at, this is point D. I said I was getting better. All of a sudden not. This is F and this was C. So what's going on here? Well, we have this other force, we have this other member, DE, is actually supporting that, right? Now, it comes in like this, but typically we don't like to do that. We like to look at it as we've got a dy and we've got a dx, don't we? More than likely that thing has to be pushing up, right? It's in compression. So that's why I say dx is going to the right and dy is going up. I'm going to erase this. Well, then what do you think's happening here at this other location? Well, the vertical post is probably pushing it back down here, right? As far as the CY is concerned. What's the CX probably doing then? If you look at that picture, it can only be doing one thing, can't it? It's probably, yeah, pulling back this way, isn't it? Essentially being in tension. Okay. Now it's not in tension because it's a CX or CY. Remember Wednesday I said X and Y is going to be going left and right, up and down. If it's a force member like AB or CD, or in this case CDF, that would be in compression or tension. But we're looking at individual points now. We're looking at reaction points, just like we had been on the whole system. So they won't be tension or compression. Okay? Essentially it is. It's pulling it back. But it's kind of in tension and compression at the same time, isn't it? If you looked at it from that standpoint. Now we're still not done with this free body diagram. As much as I would have liked to have moved on, we still have to put some distances in here, don't we? That distance is 10 feet. This distance is 4 feet. Probably should have given the 14 feet, but I think I can calculate that. So now that's the free body diagram. That's everything that's going on there, right? That's the external force for the 10,000 pounds, and it's what this D position is what the member.
You don't need the weight of the beam?
Oh, yes, I do. That was how much?
1,500 at 7 feet.
Normally, I don't worry. We just don't worry about the weight of the beam, and that's why I keep forgetting that. So thanks for reminding me. But I would suggest that potentially you won't see that on a test because that's just not. Normally, we just neglect the weight of the beam. So.
That's why I did that on the last quiz and it cost me points.
Do what?
I said I neglected the weight of the beam on the last quiz and it cost me some points.
But it, excuse me, it was spelled out too, I believe, wasn't it?
Yeah, I guess it did.
Yeah. If it's not spelled out, you can neglect it and then you would have a good argument if I marked it wrong. Okay, if it's not spelled out, you wouldn't know what it was anyway.
Right.
So later on in the semester, we might talk about how you should know the weight of the beam. It shows you in the spec of the beam. It tells you what the W is per foot, what the weight is per foot, and you would be able to spec that out. So let's see, better give that arrowhead a little bit of practice there, hadn't I? Okay, so now that's everything, right? Thanks for reminding me on that. Okay, so let's see. Can we do this? You could probably do that in your sleep now, can't you? Somebody say yes, please. Lie to me if you have to. It's Friday. Summation of the forces in the X. This is not something that we haven't been doing. We just keep doing this over and over. It's about to put some of you to sleep. I understand that, but you have to bear with us. Minus CX plus DX. So then we could say that CX equals DX, right? That's about all we know right now. Sum of the forces in the Y. Yep, minus CY. Nice thing about this is we don't have to worry about any sines or cosines, do we? Well, crap. I really don't want that anyway, do I? There we go. Okay, and then we've got a minus 1500. Pounds plus dy minus 10,000 pounds. Oh, two unknowns. But you being you now, you don't panic, right? You say, okay, I got some distances there, so I can do a moment equation. Summation of the moments. Now I can't do it today this time, can I? Excuse me. I can either do it at C or D. Either one of those really doesn't matter. Okay, so if I do it at C, based on crowd input, CX and CY go away, don't they? I'm left with DX and DY, right?
No.
No, remember, anytime I finish the sentence with right, it's not right. Okay,
Right.
DX goes away, doesn't it? Because it's going through the point. Okay, so don't let that get you tripped up. There's no distance for DX, so that's plus. We can get rid of that. So what's the 1500 trying to do relative to C? It's trying to make this thing go clockwise, right? Negative 1500 pounds, 7 feet, plus dy at 10 feet minus 10,000 pounds at 14 feet. We can solve for dy now, can't we? Everything else goes to the other side of the equation. It becomes positive. So 10,000 times 14 plus 1,500 times 7. And then all of that divided by 10. And let's see. I'm hoping that you end up with 15,050 pounds.
Yeah.
Pounds. We said that dy was going up. It came out a positive value, so it is going up. Okay, so we can solve for CY now. This is 15,050. CY goes to the other side of the equation. we've got 15,050 minus 10,000, that's 5,050 minus 1,500, 30 what? 3550. 3550 pounds. We said that CY was going down. It came out of positive values, so CY is going down. Right about now, you start realizing that ruh-roh, I can't solve for DX or CX, can I? All I can say is they're equal, whatever they are. So you throw your pen down and go home, right? No. We just go to the next member.
On that forces in the Y,
Yeah.
everything doesn't go to the other side. You just take CY to the other side.
Oh, yeah.
Right?
That's right.
You get a different answer.
You what? No,
If
you shouldn't.
take CY on the other side, you have minus 1,500 plus
Yeah.
5,050 minus 10,000.
Which is what I said, but I didn't. Did I say CY goes? We got it on video. Did I say CY goes to the other side and becomes positive? I don't remember. But that's what I should have said. And then it's 15,050 minus 10,000 minus 1,500. Right?
So you get a negative number.
No, you don't. 15,050 minus 10,000 is what? 5,050.
Oh, I was doing. Sorry.
Yeah.
I was doing 5,000.
That's all right. That's quite all right. So as long as we end up with the right answer, that's all that matters. Okay, so now we can't figure out what CX and DX are, so we just go to the next member. So let's see. Oh, and you could, if you wanted to, you could go in there. And yeah, that's too busy. We really don't need to worry. I was saying we could go in there and put those forces on there, but that we really don't want to do that. So let's see what. Excuse me. What are we going to go to next? Do we want to go to a post, or do we want to go to the brace? I'm thinking let's go to the post. You know what? If we're Brian, go ahead. I'm sorry.
No, sorry. I have a question. So CY is significantly less than 10,000 pounds. Is that because it's acting across a longer lever arm? I'm just trying to visualize this because if we've got that pivot at D.
Well, most of the force is going to be. Think of it as a teeter-totter, maybe.
Yeah.
Most of the force is being held up at that fulcrum point, isn't it?
Well, it seems like.
And then it gets back to your CY is so much farther out, it doesn't have to work as hard
Okay.
as the other side. So again, think of that the teeter-totter. If you put the lard ass out on the short end, don't you? And the skinny guy out on the other end. Okay, so I always have to be on the short end.
Yeah, so it's almost twice as long a lever arm and almost half, a little less than half.
Yeah. So that kind of it gets back to if it doesn't quite look right, if it doesn't pass that test, then why not? And we just figured out why not in this case. Okay. You would expect if dy was closer to the middle, that those two forces would kind of be. Intuitively, you know that, don't you? So, and it gets all the way back to kindergarten. You know, when you were a preschool, when you were going to the. Wait a minute, they didn't have preschool when I was a kid. Too old. Telling the age thing. Okay, so we go to the post. List all the forces on that. We decided we had this BX, right? What was that number? 11,070? Well, then we had, excuse me, down at the bottom we had this A trying to push that back, didn't we? Was that 11,070? I'm looking at the book here and kind of cheating. What else do we have? Anything else? Oh, we had 1400 right at the center here. And then we've got a pin location here and a pin location here, don't we? And this is C up here. And this is E. Excuse me. I don't even smoke. Now, this is kind of where it gets a little confusing. CX, when we're looking at this member CDF, CX is going to the left. Okay? So the post was pulling this way, right? So when we look at the post, that horizontal member's pulling back to the right, isn't it? Whoops. Have to erase that. All we know about is it's CX, right? Does that make sense? Well, crap. That's not good. Does that make sense? It's got to make sense. Doesn't make sense, you best be speaking up.
So then would that make that EX as well?
Well, we'll have to look at EX. Okay, so this is CX is going this way. And again, think of what the horizontal member is doing to this. If that horizontal member is, there's a brace right here and you've got this thing pulling down this way, it's pulling that, it's trying to rip it out of the ground and trying to pull it at that direction, isn't it? So the member that's out here is trying to pull this thing all out. If it weren't trying to pull out, then this 11,070 wouldn't even be there, would it? That's why B is having to push back. The wall has to push back because this is trying to rip and pivot this way. Well, that member is actually pulling against it. So you're always looking at, and by the way, I forgot to label this, didn't I? Member AB, is it? A, E, C, B. Okay, so, and there is no BY. So there's a CX. What did we decide CY was doing? CY we said was 3550 going down, right? Well, now that CY is actually going to be right here, 3550, pushing back up, isn't it? Because again, this member CF is trying to go up, so the post, it was trying to rip it up, and the teeter-totter effect, if you will. So the post was having to hold it down up here. So now we're looking at what that member is doing to this post. Well, it's trying to tip it back up. So this is always what the other member is doing to this member. That's why it has to reverse. Okay, so don't let that get you. Well, then what's, excuse me, what's,
If you did have the wrong error, it'd be like any of the other things we've
it's
done.
going to come out a negative value.
Okay.
And then you'll know, whoops, I guessed the wrong direction. Because it can get kind of iffy, which one's right. Well, don't waste a lot of time trying to decide which one's right, because if it comes out negative, then you know you guessed the wrong direction.
Yeah, but you're not going to get a different value other than the negative.
No, not unless you have too many of them guessed wrong. I guess you might end up with something screwed up.
Okay.
Or if you forget, we figured out what CY was, right, and you forget to reverse it the next go around, it still should, I think it's, because of the value, should still be right.
Okay.
So it's just you're going to get the wrong sign. Then what's happening at E? Okay, now it's what the brace, yeah, there it is. It's what the brace is doing. Well, that brace is going to be pushing down and to the left, isn't it? It's going to be in compression. So that brace is actually doing this at E. EY is doing that. EX is doing that. The distance here is 2 feet. The distance here is 12 feet from A. The distance here, 14 feet. And that's all we need, isn't it?
We have a value for that CX.
Oh, not for CX.
That was
We just know that CX.
15.
Huh? Do we have one at the top? Up here?
Not for CX, yeah.
We have BX.
The book has it in there already, we just have to.
Oh, we haven't calculated. You cheaters. Oh, shoot. Yeah, all we know is CX and DX are the same. And that's what's nice about it. Eventually, what happens is, it's almost like when you play free cell or solitaire on a computer, and all of a sudden, things just start falling out, and it's done. And that's what's going to happen with CX and DX. Boom, we're going to find one, the other one's going to be there. You just be able to plug them in and keep going. Okay, so a lot of that stuff, you're kind of working in the dark, and then all of a sudden, boom, the light comes on and you're good to go. So here we go again. Sum of the forces in the X equals 0. You got minus 11,070 up there at the top. Haven't coughed all day. I guess what it is, I'm allergic to you guys. Plus the X, either that or it's just from all the talking. Minus EX, right? Plus 11,070. Well, what do we end up with there? CX equals EX, don't we? The two 11,070s cancel out, and CX minus EX, well, if you leave CX where it's at, put the EX on the other side, then you know they're equal. Sum of the forces in the Y.
Do we not use a AY for that, or no?
Oh, I forgot to put it in there. What did we figure that was?
13,800.
Thank you. Yeah, because you're supposed to put every force that's acting on that member. Okay, so I put the AX and forgot about the other one. So thank you. Okay. That helps, because now we can use that. Boy, our numbers were really that's where your number would come out wrong, Jeff, if you forget to put a force in. So we'll get that one in there right away. 13,800 plus or minus 1,400 for the weight of the beam that I kept, or the post that I kept forgetting. Then we got the CY here, which was 3,500. That's plus 3,550. Minus EY, right? That's the only unknown. So if we put EY on the other side of the equation, 13,800 minus 1,400 plus 3,550. What's that come out to? 15,950. 15,950 pounds. It was positive. We said it was going down, so since it's positive, it is going down. Then I would look back up here and make sure that I don't have anything that's equal to EY, and I don't. The only thing we're still missing is the X stuff in it. So I'll do a sum of the moments. And it doesn't matter. Now, it does kind of matter this time. It absolutely does matter this time. Somebody tell me why it matters.
You pick a point where you have unknowns.
Because you can't have a movement at BY.
Well, you could, yeah. Yeah, you still could. But what Clark said, pick your moment at one of those two unknowns and you just canceled out one of your two unknowns. So now you don't have that unknown. So we can solve for CX or EX. If we did the moment at A, we would still have EX and CX to have to deal with. If we do the moment at C or E, we only have one unknown. So if we, and we couldn't do that on that horizontal member, right? Because the X's were both going through the points. So, excuse me, it's like you make a call. I'll do it at C. Just to be consistent, I always like to give my first part of my alphabet the benefit of the doubt. So we go, if we go about C, we've got this 11,000 here, 11,070, try and make this thing go clockwise, right? Or excuse me, counterclockwise, which is positive. So we got 11,070 pounds at 2 feet from from C. The 3,550 goes away, the 1,400 goes away, the EY, which we know now, goes away. EX is still in there, isn't it? It's making it go clockwise, which is negative. And it's about 10 feet, isn't it? 10 feet from, I put all those numbers relative to A, and they really need to be C in this case, C or E. Then we've got the 13,800 goes away because it's going through the point. And we've got this 11,070 trying to make it go counterclockwise, which is positive again. 11,070 pounds times 12 feet. That's it, isn't it? That's all the forces that the moment takes care of there. So we'll move that up a little bit so you can see it. So then we could solve for that. Excuse me. EX goes to the other side of the equation. These stay like they are, so it's 11,070 times 2 plus 11,070 times 12 divided by 10. And hopefully that comes out to 15,500. Pounds. We said it was going to the left. It came out a positive value, so it should be going to the left. Oh. Now. Did somebody punch that in? Make sure.
Yeah, it works.
Okay. So we know that EX is 15,500 and we know that CX is equal to EX. So therefore, CX equals 15,500 pounds. Oh, and you know what? I'm leaving something off of there on all of those that I need to put. CX is going to the right, right? On B or A, B. And it do make a difference.
So it's part of your answer on A.
Yeah, it should be on all of these. So I'm going to have to get my eraser out. Let's see, one right there too in there. So why does that make a difference, you ask? Go ahead, ask. I don't care.
Why does that make
I'm glad you asked. Because you're looking at different members at different times, aren't you? So you have to be specific as far as you have to give them your frame of reference, if you will, with respect to the frame, because you have the same point on two different members. So on this first one, that would have been on wrong pad. On let's see, member. What was that member? CF. Thank you. That would be part of my answer there. Well, while we're at it, while we're here, up here it said that CX was equal to, come on, CX was equal to DX, right? So DX equals 15,500 pounds, and DX was going which way on this one? To the right. On member CF. So that will be part of your answer now. So that means you've got another part of the answer that you can possibly get some more points. That's the way I like to look at it. Go ahead.
Alright, so when we found CX, that CX right there is going the opposite way. Does that make a difference?
The only thing it makes a difference on is if you don't put this on CF on there. I mean, DX is going to, it won't make a difference as far as the value is concerned. No, if CX is still 15,500 no matter what. Now, depending on which member you're looking at, it's going a different direction. That's all there is to it.
Okay. If we would have started on that beat first,
On,
AB,
On member AB.
yep, so we
Uh-huh.
would have ended up with the answer, CX equals 15,500 to the left, correct?
no. If we just started with this one first?
Yeah.
No. Because that horizontal member is still pulling that no matter what. You could in theory you could guess these two wrong if you were looking at that one, and your directions would be wrong, but the answer would be right. But you could, yeah. But think of it, and you got to think in terms of this overall picture. If you've got this whole system here, even if you just had that, wouldn't this member right here be pushing back down into that? So E has to be going this way and that way, right? Okay. If you had this member here with some force on it, some weight out there, and it's pivoting about this fulcrum, it's trying to make this thing go like that, isn't it? So wouldn't this point right here have to do that? And now if we're looking at this piece right here, what's it doing to this member? Okay, so let me pull this out here. What's it doing? This has to push back down, and it has to also pull back that way, doesn't it? Because this right here is trying to make that whole thing do that. Okay? Well, then that would translate into, if that's the case, then what is this thing trying to do to this member? So let me get my eraser out here real quick. If we were looking at this member minus that piece right there, if you will, if we were drawing the free body diagram for just this vertical component, what is this trying to do? It's trying to pull it this way, isn't it? And it's trying to push it back up that way, which was this rocking motion here. So that's what we would show on that free body diagram. For those two locations, okay? The other two locations would be what was happening on the whole system, at the pin locations. Does that help?
Yeah.
Hopefully that helps some more. That's why you got to ask these questions, because there's somebody else wanting to hear it again too. Okay. Well, let's see. Are we done there? Let's see. I wasn't quite done labeling this, was I? Yeah. On member, what we call this one, AB. It's almost like if you work on a jet engine, when you look at a component, you have to tell them if it's aft looking forward or forward looking aft. AFL or FLA. Now, you have to label that so they'll know. Same thing here. You have to tell them, what member am I dealing with on AB. It's all about giving them a frame of reference. Well, let's see, do we know everything now? That's where I would have a list so that you'll know whether or not you've gotten everything I need you to have. Okay, so let's see. If I go back and look at the original picture, I know what's going on at B. I know what's going on at C. I got D both, didn't I? I got both at E and I got both at A. So we're done with that problem now. So when we found EX, we found CX, and then when we found CX, we were able to go back up here and fill in for DX. 53 minutes. But that was to explain it too. If I were sitting down and doing it, it wouldn't take me 53 minutes. So it would you, I understand that. But so
you really don't have to do number ED because you have all of them now?
no, but what you can do with ED, I'm glad you asked. So if I take member E, if I could spell member right, member DE or ED. Okay, there's that member right there. And we had here, let's see, we had DX, which we know to be 15,500, right? Pounds. We had DY, what was it doing? Was it pushing back down?
1550.
Just 1550? 15,500 or 50?
15,050.
Okay. Well, now why is that pushing down? And why is the other one? Remember, it's what the other member is doing to this, right? So D, in this case, D was going to the right and up because that's what the brace was doing to hold it up. So if that's what the brace was doing to hold it up, that 10,000 pounds is making this thing want to squeeze that back down, isn't it? And it's also pushing it to the left. Okay, so I kind of just threw that in there real quick. Well, let's see. At E, in this one, it's going to the left and down, so it's got to be going up and to the right on this one. So we got up and to the right. There's the right, and there's the up. Well, we know that this is EX, and we knew that that was 15,500, right? And then this was EY, was it 15,050?
15,900.
Huh? Oh, okay. Yeah, that's right. Oh, you started to make me panic, but then it hit me. Never mind. It was about the panic. 15,950. Holy cow. Oh, let's put that 900 pounds in there. Don't want to forget about that, do we? Which I tend to do. Here's what's nice about this. again, this one's going to allow you to walk out of this room knowing you did it right. Because if you do summation of the forces in the X equals 0 equals 15,500 minus 15,000. Getting in a hurry. I get so excited about this stuff. Believe that? It's almost as bad as CAD. 15,500. Hey, 0 equals 0. And if you wanted to carry it one step farther, summation of the forces into Y equals 0. 15,950. That's why I was starting to panic, because I forgot I still had 900 pounds here. Minus 15,050. And once again, 0 equals 0. Ah, it's a beautiful thing. Because then you can walk away knowing that you got it right. The only thing that you could walk away not knowing that if you were going to get points or not, is if you forgot to put the units in the direction. But here we are in about the 6th week now, so now we know we're not going to forget that after 2 tests, right? I'm not guaranteeing anything. Remember, I forgot questions on the whole test when I was taking tests, so we won't guarantee that, but hopefully it's starting to sink in. So now that's just a way for you to check and make sure everything's right. I didn't put the distances on there because I didn't need to go that far. All square on that?
Is their quiz just gonna be one problem?
Do what?
Is their quiz just gonna be one problem?
No. Be 3. We got 3 different methods, right?
So you gotta tell us which method.
Oh, I'll specify which, and just like they're doing here in the book. You know, they're saying, I need you to do method of sections, and here are the 3 members I want you to check. Okay, so that's, and they even threw you a curve on that one, didn't they? On one of them, it kind of went diagonal. If you did your homework. So, speaking of homework, what questions do you have?
That diagonal,
Hmm?
that diagonal, I have no idea.
What diagonal one? Got to be more specific than that. Five nine, which, and again, by the way, I told you I posted the solutions on Blackboard. Okay, so problem 5.9